Good morning, friends. Welcome back to host-tune-perform.com. And today we will be beginning up a course on infrastructure monitoring, and we will be doing a case study on Nagios Core. So Nagios Core is something which is an open source like product which is built by Nagios. Obviously, like these people also sell some commercial products, but this core is Nagios core and this is open source. So I have been working from a little while for creating up a monitoring infrastructure monitoring tool for one of my client, and hence like here I present up this case study. So what exactly you will learn in this case study? If you are a newcomer towards monitoring, you are a system admin, you are a performance engineer or a developer, and you want some insight on infrastructure monitoring, so this is the best place for you. And like how exactly all these things work, what all protocols are used, and how you can create a monitoring tool from very scratch. So this is what like I will be discussing upon in this video. And like just before we proceed further into it, let us go ahead and discuss something about client server architecture. So what exactly is a client server architecture? It might be the case you already know it, so that is perfectly fine. It may be a refresh for you. We have various clients. So we have a desktop. On this desktop we are running up the Chrome, and this Chrome hits a request to the server using HTTP. So this HTTP, what is this HTTP? This HTTP is nothing but the service. So these are the services which are being provided by your server, and the type of the service is HTTP. It can be FTP, it can be XMPP or some other protocol. The server can be of this type. It can be even a database. So these services like are being catered by the server, and the response comes back to the desktop Chrome, and like it gets the particular like page. So in between there is something called as internet, and this internet is nothing but a network, and this network is built of various components. These components can be router, these components can be switches, or these components can be like hubs or a lot of other devices. Maybe a printer, there is a printer attached to this network, or there may be a shared drive attached to this network server. So I'll just say SD. So there can be various other components which can be attached to this particular piece of infrastructure. So this is nothing but a client server architecture, and this is a very simple architecture which you are seeing in front of you. It has only few computers and only a single server. In like actual world, the things does not go like this. In actual world, the things something goes like this. Also, this is like also the minimal architecture, and in actual world there are a lot of routers placed, there are a lot of switches placed, there are a lot of authentication servers, database server, file server, and a lot of client machines. And in the similar way, there are thousands of computers in an infrastructure, and thousands of other machines, say router. So what will happen when a person like over here hits a request to the server? Say a person comes over here and he hits the request to the server, but this particular switch is not working, right? So if this switch is not working, this particular request will go to the switch and it is not working, so it will continuously get failed. So there is a demand. What is the demand? Demand is you should know which switch is not working, and that too as soon as the switch starts behaving abnormally. Because say for instance you are building up a banking software, and in that banking software this switch goes wrong, and your clients are trying to like log into the website, do internet banking again and again, and like it has been like few hours, and then the customer call the customer care and tell them that this particular website is down, and then they reach to the development team or the infrastructure team or the like network team. They look into the issue, and first they will say that there is problem with the server, so they will check the server. So they will say that okay, the server is fine. Then they will check the authentication server, okay, this is also fine. Then they will check the router, okay, this is also fine. At the end they will come to know after a lot of time that this particular switch is not working. So this was what how it was used to be done before, and now like there was a requirement for the people who were creating up the switches. So these particular switches or routers or all of these things are created by few companies, and some of them are like Cisco, like Juniper, like Synology, like TP-Link. So these are few companies which build up this router or switches. So when you say that these people build up this router, what they should do is like they should add upon a software, or you can say a firmware, a software which is being like hard coded or being burned on the microcontroller or the chips of these routers or any electrical instrument. So obviously I'm not an electrical engineer, I'm a software engineer, and like these software are embedded into these routers. So there was a requirement, the at the end the agenda is like there was a requirement to monitor these routers, and hence there were few protocols built upon to monitor these things. So these protocols were nothing but, you can name them as SNMP, NetFlow, then you can name them as SFlow or JFlow. Again, these depends. So the company which is Juniper, he created up the router and said like I will name my protocol to be JFlow. Cisco said they will name it to be NetFlow. Then there is something called as SFlow and IPIX, I guess. So these are some protocols which were built for general purpose. So we will talk about them in detail. But let us try to understand how exactly this requirement came into picture and why was monitoring required. So here there was few protocols which were applied and few softwares which were like loaded onto these switches and routers. And what was the purpose of these softwares? The purpose of the software was to make sure to understand the health. What do we understand by the health word? The switch health means whether the switch is working or not, if it is not overheated. If the switch is overheated, it means there is some problem. So switch should not be overheated. So it should work properly. It should not be overheated. All the ports in the switch should work. And then there is something like we can say like what all traffic is moving on from the switch, how many requests are coming on. So there are different aspects of monitoring. So all of these aspects are covered up by different protocols. And if you're planning to build up an infrastructure monitoring tool of your own, you will have to understand all these protocols one by one. So again, I will be going deep into them again, like in each one of them in further classes. My intention for today is to make sure you understand the words, learn the words, and at least know the basics of infrastructure monitoring and how it is done. So in the similar way, when we say that we are monitoring of the switches, we are monitoring of the routers, we also need to monitoring of the file servers. So FTP servers. So what is the service over here? Which is service is FTP. We need to make sure that this FTP service is always running fine. So obviously to do that, we need some software on the server, right? So we need some software on the server. Similarly, for database server, we need to monitor the MySQL services. Then for web server, we have to manage the HTTP services. So these are nothing but few softwares which have been installed on the system, and like as soon as something happens, say the CPU of this file server goes above 90%, it will throw an alert. Or you can say that if the memory of this database servers goes above 85%, it will throw an alert. So as soon as that particular thing happens, the person comes to know. So like the end customers do not call the customer care, tell them that thing is not working. Before that, before this happens, before the business like name gets ruined in the market, we come to know that yes, some problem is there and we have to find the way out to solve it. And this is why like the monitoring is done and it is important. Now let us talk about history. In late 1970s, there was no monitoring tool, and there was like very simple architecture which we used to follow at that time. In late like 1982 or something, SNMP was developed. So SNMP was the first protocol which was developed for network monitoring. So again, the monitoring can be divided into few parts. One is network monitoring, which we say we are doing it for the router or the switch or these storage devices or the printers, or like how much CPU is being used, because the switches and routers have their own memory, they have their own processing capabilities, so CPU. So these all things like matter for all of these things, right? In the similar way, like when these companies started developing all these things, there were no monitoring tools. So first, like protocol, which was developed by SNMP, which was for health check. So in network monitoring, we have two parts. One part you can say is the health check, and second is traffic analyzer. So in the next slide, it will be more clear to you. Let us take a short look now. That is TA, that is traffic analyzer, health check and traffic analyzer. Health check is if the switch is working, it is not overheated, all the ports are working, and everything is doing fine. This is health check. What is traffic analyzer? Traffic analyzer is what is going inside this switch, what is being like, what request is being catered upon it, like getting back to the desktop. So if 100 people are connecting up to your web server using this switch, all those records can be fetched and checked. So this is nothing but a traffic analyzer. Then we can monitor the desktop and all the services of the desktop, and in the similar way we have like a lot of other things. These desktops can also be checked for health, and they can also be checked for traffic. Again, so let me just unsave this and go back to my client server architecture, and let us try to understand how exactly this happens. So whenever this router now, it has the capability like this particular monitoring, any tool, you can say Nagios, you can say PRTG, you can say solar winds. So there can be any monitoring tool which you can use. There are two ways of checking these things. So one way is a simple way where you will create a like server over here. So you will create a server on this desktop, and it will ping it. It will ping this router and ask it, are you okay? The router will say, yes, my all ports are working. My temperature is also good. Everything is good. And it will come back to it and say, yes, I am okay. So this is something like which you have to do on regular interval, and this is not close to the real world. Say for example, the router, this particular port P1 stopped working, and as this port stopped working, it will not throw a message to this desktop. No, not to the server. What will happen? The server will first ask it, and it might happen after few seconds of this port being not working. So it will ask this router, your port is working, and it will check, oh, it is not working from last 3 seconds. Okay, I will say no, it is not working. It will say this to the server. So obviously you can convert this desktop to the server. You have to install some softwares. We will talk about them in detail. We will talk about each and every protocol in detail in the upcoming videos. So this particular video is just to give the glimpse of how actually a monitoring tool is built, and what all tools are available in the market, how each tool is different from each other, and etc and etc. So as of now, the first way is this, which is we do the poll and then we get the response. And what about the second way? If we talk about the second way, what happens is there is a trap, an SNMP trap. For example, what is an SNMP trap? So this is the second mechanism. So all the protocols follow these kind of things like NetFlow, SFlow, SNMP trap. These all follows this kind of mechanism. And what is the mechanism? The mechanism is there is some software installed on the router itself. So the server does not poll the router again and again. The mechanism is there is some software installed on this router itself, and this router like sees the health. As soon as the health or the temperature of this router goes above 70 degrees Celsius, it will throw an alert. So this is something which comes closer to the real world. So as soon as the router is above the 70 degrees Celsius, it will throw an alert to the server, and from the server an email will be sent up to the client or the person who will have to check where is the problem, and email will be sent from here, right? But it becomes more realistic because as soon as this happens, the router itself tells the desktop. So in any normal case, in any design, may it be any tool, these two things can be done. And obviously the configuration settings. So in monitoring, if you are using a pre-built tool, the major things which you have to learn is the configuration settings. What all configuration settings you have to make in the router, and what all configuration settings you have to make on the server. We will talk about them, each one of them slowly and gradually coming up. Let us just take a glimpse. So this is the second way, and the second way is more closer to the world. So let us discuss about another difference between these two ways. In the second way, there might be a scene like all of these servers are sending up the response to this particular like server. So in this particular case, this is the client, this router is the client, and this software which is on the desktop, which is hearing up and like sending up the alerts, is the server, and router is the client. This also follow the client server architecture. And here this also like this will behave as a client, and this desktop will behave as a server. So these all things, each of them are being monitored, and each of them are sending up their particular health status, traffic signals, data, everything to this particular system, which is the server. And if this is the case, there might be an issue that this particular server gets overloaded, right? Because all of them are sending to this server. So it is always preferred to build up an monitoring tool which is a set of all the protocols. So like you can do one thing, you can keep these few services like which are not so important in a way that this server is polling them and asking them, oh, are you working fine? Oh, are you working fine? Oh, are you working fine on these services? And you can choose few others for which the real-time scenario will go high, like the CPU or memory or the temperature. So it will say just it will just like give the message to the server by itself. So this will become more real time. So in the real scenario, you should always try to build up a mix and match so that even the server does not get loaded and even the real time scenario challenges are being solved. So this is nothing but the basics of why monitoring is required and like how exactly this is required and at what all places you need to do the configuration and at what all places the softwares are required. So you do not need to install all these monitoring softwares on these particular routers or on this desktop. The client softwares are installed by the companies themselves. So the router will have the software for monitoring which will be installed by Cisco. You will have to do the configuration. Similarly, Juniper router, these are the companies who build these routers. Synology will build up the router and say that, okay, I am put up this software, you can configure it this way. They will have a proper documentation of configuring all these protocols. So again, TP-Link will have these like particular routers and say that you can configure S-Flow or you can configure maybe some SNMP or Harmon. So these are a few protocols for network monitoring. So you can configure them, but software will be installed by these companies on the hardware by themselves. You might have to install the software on the desktop where you are creating up the server, which is actually the collector, which is collecting all these information, monitoring information. So here we know like why monitoring is required, what is the history, and we have also discussed like how exactly things happen, and you should be having a glimpse of each one of them. So if I just go ahead and let us now discuss something on this particular case study. So this is particularly on Nagios like core, and like these are some products, these four are some paid products, which is Nagios network analyzer, which is Nagios XI, this is not 11, this is how they call it. Then we have Nagios fusion and then Nagios log analyzer. So to put up words into your mouth, I will say that this log analyzer is nothing but a tool which is similar to Splunk or Snowflake. So Splunk or Snowflake are also the tools which are used for log analysis. So what exactly happens? As we discussed, like we need to monitor the network health, we need to monitor the network traffic, then we need to monitor the machines which are Windows or Linux machines which are our servers, and then we need to monitor the services. So these machines, these servers like provide a lot of services. They can be FTP servers, HTTP servers, XMPP servers, SSH servers, and similarly a lot more protocols are there. So all of these services can be managed So using all of these different protocols. So if you need to check the network health, you will have to use SNMP protocol. If you need to monitor the traffic which is going on, then you need either Armon or NetFlow or SFlow or JFlow. So JFlow is something which is built by Juniper. These two, IPFIX is the actual standard for network analysis, but these protocols are not built up entirely on IPFIX. SFlow is again like a protocol which is built by Inmon, but they say that this protocol can be used in a generic way, and a lot of companies use them. Even Synology, they have few routers which are based on SFlow. Cisco is basically based on NetFlow, and SNMP and Armon. This is a very basic protocol, and this is being followed by almost every router or switch, every good router or switch. So there might be a case you if you are buying a router which is of only 2000 rupees, it does not have any of these protocols. It means you will not be able to monitor it. So you need them to monitor it. So again, these all are nothing but the APIs. So this particular SNMP protocol is not thread safe. So the application server should manage the thread safety, and they should synchronize all the threads before it reaches SNMP. So again, these protocols send us the information, and like they send us information like every 10 seconds, 1 minute. It depends on the configuration, and hence they produce a lot of data, a lot of logs, and these logs are saved into database. So when these logs are saved into database, we need some kind of mechanism and engine to analyze these logs, and this is a paid tool from Nagios. And similarly, there is Splunk or Snowflake. Then there is Nagios Excise. This is a tool which is for live monitoring. So if you people know about Angular, in Angular there is something called as two-way binding. You can bind the data which is visible on your HTML with a variable which is running at the backend. So you can bind that variable with these services. So as there is a call or there is something which is being sent by SNMP trap, this particular thing will be live monitored and will be shown on the screen at the real time. So this is something like which you can use if you want to build up the monitoring tool for yourself. You should know that there should be a live monitoring mechanism. So these things are all like mostly they are doing the live monitoring, and even like they are showing up the graphs, different visualization graphs, because of which they are getting up paid so much. So the difficult part lies in the visualization. All of these APIs, you can follow up different protocol pages and you can use the APIs for free, but showing them on the front end, showing different kind of graphs, maybe candle graph or maybe time series graph, or there can be a lot of other graphs which you can show, like maybe this is response time, the load graph, the CPU load graph, and the memory utilization graph. So there can be a lot of different graphs which might be requiring a lot of different analysis. So these are the tools which provide the expertise, but the data and API can be used for free. So Nagios core itself uses all of these protocols for monitoring network traffic, the health of the servers, and the services. So these are the basically the things which are being monitored by Nagios core, and this Nagios core is open source, and like it also have plugins. It uses 50 plus, it has a package of 50 plugins as of now. On the date I am building up this video, they say that it is necessary for you to install these plugins, and without these plugins this core will not work properly. And at the end, Nagios Xi is itself based on Nagios core, but it has more efficient configuration window. Like you have the UI for configuring things. You do not have to write in an API. So there are like the it has the UI, and then you can say that this particular software also have the graphs for performance reading and all other things. Then you have something, a paid tool from Nagios, which is network analyzer. This is nothing but something where you can analyze who is coming into your system. This is also for the security reason. So you can see, oh, my server is in India, but there is a request which is coming up from China. So you suspect it. So there should not be a request coming up from China, and you say that you need to block this IP address completely. So you block it in the Cisco Cisco software if you are using a Cisco router, but you can analyze it using this software. And if your infrastructure is divided into various geographies, say you have an infrastructure in India, in US, in London, then in Australia, and you need a centralized server to manage all of these monitoring tools. So you say that you have an infrastructure in India and you put up all these three tools in India. Then similarly, you have an infrastructure in US, you put all these three tools in US. At the end, you will need Nagios Fusion to make sure that you are able to manage the data which is being taken by all these three at one place. There are hierarchies, like your CEO will not look at a single geographical area. He wants to see all the geographical areas together, and this is what the job which is done by Nagios Fusion. And like studying up this case study, you will also be able to understand different other monitoring tools. Now let us take a look on there are few other names in monitoring, some such as New Relic or Dynatrace. So what are the advantages of using these monitoring tools? So these are application monitoring tools. As of now, what we are doing, we are monitoring the infrastructure, the services of the infrastructure. But say your application is made on Node.js, or you're using Apache Tomcat. So you are doing a lot of making a lot of servlets using Java, or maybe you are building up your website on IIS, which is C Sharp MVC structure, maybe web API, you are building up some web APIs. So if you are doing all of these things, so you can say that you can also monitor the application. So there is something called as fine tuning of the application. So you can know how many abstract classes you have made, how many times you have used static keyword. Similarly, there are a lot of things which you should know about your application, and hence you also need a different monitoring tool for application monitoring tool. But Nagios is something which is not capable of doing a deep perspective in all of these things, and hence there are few other tools such as like Dynatrace or New Relic which are in the market, booming up in the market very well. But basically, if you are trying to build up a monitoring tool of your own, you will have to learn all of these protocols, and like these are very simple protocols. You will go with each one of them slowly and steadily. For example, WMI is Windows Management Instrumentation. This is a software which is already installed on Windows. All you need to do is you need to connect to it from remote, and you need to hit an API, and it will give you all the information. So mostly like all of these work are done using command line interface, and you need to hit up an API which actually targets the CLI of your server machine, and that CLI fetches up the data, and you need to send it back using the API. So there can be different architectural style which you can follow to build up your software. But basically, this case study was to make sure you understand all the products of Nagios, and you can compare it with the other products. Why I chose Nagios? Because this is an open source software, and you can use this completely free in your business environment, even commercially, right? So this was all about Nagios and infrastructure monitoring and building it from scratch, an overview of all of it and what all things we will study in this entire course. Next, we will start off with a detailed study on SNMP, that is Simple Network Management Protocol. Thank you guys. Have a great